all of these equations, and we should be able to, talk about the details and give me a story that goes with each one of these position equations. What I've highlighted is what we call the standard position equation, and we derived that earlier in class. This is based on constant acceleration. It says that the position of an object as a function of time is x naught, initial position, plus v naught t, initial velocity, plus 1/2 at squared. And so if we look at this first equation, this object says x of t is equal to 3 plus 5t. This is a very basic, honestly more of an algebra 1 situation where this one has a starting position of 3, so it's 3 meters to the right, and then it's got an initial velocity of 5. However, there is no acceleration term. That means that the acceleration is 0, which means that that initial velocity of 5 is actually the velocity because it's not going to change, right? If it's got an acceleration of 0, then by definition it will be a constant velocity. And so this object is started 3 meters to the right and it's moving at 5 meters per second to the right every single second. So at t equals 0, it would be at 3. At t equals 1, it would have went to 8, and then so on. It would just go to 13 and then 18 every second, right? Every second we can expect that thing to go 5 meters more to the right, because that's what it means to be moving at 5 meters per second. Again, both of those things are positive. Started to the right, moving to the right. That's what it means to be a positive velocity, right? You're increasing your position. Now, if we look at number 2, it says x equals 8 minus 4t. Well, this is an initial position of 8, but it's got a negative velocity, right? The v naught is equal to negative 4 meters per second, meaning it started to the right, and then it's moving left, and it happens to be, in this case, going towards the origin at a speed of 4 meters per second. And in this case, the math is pretty easy. We can actually figure out pretty easy that it will reach the origin at 2 seconds, right? 8 minus 4 times 2, right? It will take 2 seconds for this object to then travel the 8 meters per second back to the origin. And after that, it will then continue to go left and just go away from the origin at that moment. But the whole time it is traveling at a speed of 4 meters per second squared, or 4 meters per second. It just happens to be going left, right? Definition of a negative velocity. And again, it's got no acceleration. And so it will just be traveling left at 4 meters per second for eternity. All right, look, case 3. Case 3 is even easier. There's no constant term out in front, which means the original position is just 0, which means it starts at the origin. In this case, it just moves to the right at 6 meters per second forever, because the acceleration is also 0. Fourth one, the most boring case, probably never even see it, x of t equals 10, right? This has an initial position of 10. It's got no velocity term. It's got no acceleration term. It literally is just standing still at x equals 10. V naught is equal to 0. A is equal to 0. We're not going to change our velocity, so we're just going to stand there. If you graph this as an x versus t graph, it would just be a horizontal line. All right, number 5. Now that one doesn't have an initial position. It doesn't have an initial velocity. So this guy starts at rest from the origin, and the acceleration is 8. Now remember, a little tricky. Remember, this term here is 1/2 at squared, and we already discussed where the half came from. We'll discuss even more where the half came from later on with a more calculus derivation, but we did discuss algebraically that that half is there. And so when you see this 4, it's really 1/2 times 8 t squared. Okay, so this starts at rest from the origin and has an acceleration of 8 meters per second squared. So this object is going to speed up and move to the right faster and faster and faster. Specifically, like after 1 second, it is moving 8 meters per second. After 2 seconds, it will now be moving to the right at 16 meters per second. That's what it means to have an acceleration of 8 meters per second squared. It means it will increase its velocity by 8 meters per second for every second of that. Okay, look at number 6, 10 plus 3t squared. So this guy is starting to the right, no initial speed, so it starts from rest, and then it accelerates at 6 meters per second squared. So this guy also started to the right and will move to the right faster and faster and faster. Again, this is also speeding up. speeding up to the right specifically. And then this whole time, actually, on 5 and 6 is going to be moving right and away and away and away from the origin, right? We're just increasing our velocity in both those cases. All right, 7. Now, 7 gets a little trickier. The rest of them get a little trickier, okay? 7 has -5 plus 16t minus 4t squared. All right, so this -5 says that it has a starting position of -5, so it starts to the left of the origin. The 16 indicates it has a starting velocity of positive 16, which means it's going to move to the right initially. This -4t squared indicates it's got an acceleration of -8 meters per second squared. That means, remember, acceleration, definition, the increase or decrease of a velocity. So a -8 meters per second squared means you're going to decrease your velocity by 8 meters per second for every second. So think about this. If we know that it's accelerating at -8 and it started at 16, think about how long it will take for this object to stop. And think about it, it's only going to take 2 seconds. It's got an initial velocity of 16. It's got an acceleration of -8. That means this object is going to slow down by 8 meters per second for 2 seconds, boom, boom, and now you're going to be at 0. After that, right, because it's going to stop just instantaneously at 2 seconds. After that, it's going to continue to decrease its velocity by 8. So then it will actually speed up and go left. Now, if we are interested in where it was located and all those things, well, then that's the whole point of having the position equation. We could just plug in those times here to figure out where it was located at 2 seconds. Okay? Start at -5, starts moving to the right, slows down and stops, but then actually speeds up as long as it continues to do that acceleration. All right, looking at 8, starts at 8, starts moving left, but has a positive acceleration of 2. And so it's going to move left at the beginning. It's going to be slowing down. It's going to stop, and then it's going to speed up. And this one's really easy because, look at it. If it's got a -2 meters per second velocity to the left, but it's increasing its velocity by 2 meters per second every second, that means it's going to take 1 second and slow down, stop, and then after that, it's going to continue to then increase its velocity by 2 meters per second for every second. So every second after that, it's going to get 2 meters per second faster, and eventually, right, it's going to go left, it's going to stop, and then it's going to start moving to the right. All right, this guy, 20 minus 12t minus 2t squared, starts to the right at 20. It's moving to the left initially with a 12 meter per second speed, right? Speed is the size, and the negative is the direction. Again, velocity is a vector, size and direction. The acceleration is negative, which means we're going to decrease our velocity by 4 meters per second for every second. But again, our velocity is already negative. Velocity is negative, acceleration is negative. The acceleration is going to make our velocity more and more negative, which actually means we're going to be moving faster and faster to the left. Again, if velocity and acceleration are the same sign, you're going to be speeding up. A negative velocity with a negative acceleration, speeding up. Positive velocity, positive acceleration, speeding up. It's when they disagree is when you're going to slow down. And again, if we look at this last one, we start at -40, but we're moving to the right initially at 5, and we have an acceleration of 6. So we start way to the left, but this entire time we're moving to the right and we're speeding up, right? We're increasing an already positive velocity, speeding up. This is number 9, is decreasing an already negative velocity, which is also speeding up. And so I don't think it's obvious when you look at number 9 and 10, both of those are speeding up. Again, looking at 8 and 7, originally, they both actually slow down. The velocity and accelerations disagree on sign. So 7 and 8 are initial slowdowns. Eventually, almost everything speeds up if you keep accelerating because you've changed your velocity by so much. Where 9 and 10 are speeding up the entire time. And again, 9 is moving left the entire time and it's faster and faster, and 10 is moving right, faster and faster to the right. All right, so that's looking at all these position equations and being able to write a story. Let's look at now the velocity equation. So I'm only looking at this top case. I don't know why it won't let me move down farther than that. Oh, I understand. Oh, man. That's going to be no good. Okay, let's look at the velocity equations. Number 12, the velocity equation says that your velocity at any moment in time is what you started at plus what you did and for how long. I mean, it's the definition of velocity, right? Right? Your velocity is a function of the time spent accelerating plus where you started. So if you look at number 12, this is just a velocity of 5. This is just a constant velocity of 5, acceleration is 0, and you're just moving to the right the entire time at 5 meters per second. You have no idea where you started, but you're moving to the right, clearly. Look at 13. It's got a negative velocity and a positive acceleration, right? Negative velocity, v naught, is -8, where your acceleration is 4. And if you think about it, you're going to move left, you're going to slow down to 0, and that's going to take 2 seconds. Because after accelerating for 2 seconds at 4 meters per second, right, you're going to increase your velocity by 4 meters per second for 2 seconds. Well, that's going to take -8 to 0, and then you're actually going to speed up to the right after that time. If you look at 13, this is a negative velocity at the beginning and a negative acceleration. So this is, well, you're moving left at -3, and then you're going to decrease your velocity and make it more negative. You're going to specifically decrease it by -2 meters per second for every second. So you're just going to get faster and faster left. Think about your velocity after 1 second is now -5 meters per second. Again, you went faster because you're more negative. The negative is the direction, the size is the speed. 15, this is no initial velocity, so you started at rest, and your acceleration is 6. So after 1 second, you're moving 6 meters per second. After 2 seconds, you're moving 12 meters per second. After 3 seconds, you're moving 18 meters per second. So you're speeding up and going to the right the whole time. You're just going to the right faster and faster and faster. 16, you have v of t equals 4 plus 5t. This is starting at 4 and then increasing by 5. Again, you're speeding up, moving to the right, and you're increasing your velocity by, oh, there's supposed to be a squared there. Apologize for that. The acceleration is 5 meters per second squared. And 17 is just kind of an example of starting at 12, so you're moving pretty fast to the right, but you are going to be slowing down, right? Positive velocity, negative acceleration. You can show that after 4 seconds, your velocity would be 0, so you're going to move into the right. You're going to stop instantaneous at 4 seconds, and then after that, you continue to then become a negative velocity and then move left. I'm not really sure why I can't adjust the size of the video screen to show all the bottom one, but I have a couple more here. So I'm going to go ahead and stop this video and then splice it in for the, or just do another one for the v squared equation at the bottom.